So hi everyone, I just show off myself for a second and kind of to greet everyone, and then I kind of turn off video during the presentation. Hi everyone. Um, so thanks for having me at this ScalaUA online session. My talk is about the brand new library for working with DynamoDB in a pure functional way in Scala. I guess a lot of you might think that it could be shortened to something like that. But I hope the solution I'll present you today will make you really happy while working with Dynamo database. So this won't be just another DynamoDB wrapper. A few words about the company I work in and about myself. I'm a software engineer. My name is Vlad, of course. I'm a software engineer at Kyiv. Kyiv is a global entertainment company. We develop mobile games. So here is a few kind of our products that are already on the market, like Charmkins and these cute characters from the Taste Bud game. On a daily basis, kind of we do a lot of functional Scala. Our game client's written in Unity. We have a lot of experience with Amazon Web Services, even do some ML synth on TensorFlow and other stuff. So here is an outline for this talk. First of all, I give you a quick refresher about the difference between SQL and NoSQL databases. Then the problem overview. We'll go through the current solutions and Scala world to work with DynamoDB. And then I'll tell you about this top secret until now hyperpragmatic library that we have prepared for you. So first of all, SQL databases describe a relationship between entities using tables. And we have a predefined schema for that. Also, we use this structured query language to build a query to actually retrieve the data. On the other hand, while working with non-relational databases, you kind of have key value based storage or documented based or graph based, and they don't require from you to have a statically defined schema. So you need to define only the key. And that's very convenient to have data types that changes over the time. So in case of Dynamo, specifically for Dynamo, we know that this database are famous for its high performance, greater scalability, and data model. At Kyiv, we mostly use it to store team members and payments and letter report, etc. So specifically for the talk, I've prepared a simple example that illustrates the kind of typical situation in daily job of a software engineer. We must implement this leaderboard service that had that exposes 4 endpoints. So we could kind of get users and their scores from the game ladder. We could kind of put a particular user with its score to the ladder. We can kind of retrieve profile with a rank that depends on the score. And we could create a profile itself. So, and we decide that we use DynamoDB to store the data there. Here is how the interfaces for our persistent layer looks like. Note that we structure our application using the tagless final encoding. We have this f-type with 2 hosts, 2 type parameters. I'll talk about this and about the effects and I/O in general in a second more deeply. So essentially, I/O is a data type describing a program that before returning the result type A, it performs side effects. but it could also fail with type throwable. So it kind of reminds us another type in Scala. It's either data type that could succeed with A and return throwable otherwise. So for simplicity, those of you who aren't working with kind of FP code base a lot could think about IO as an either data type. So also basically we use IO to kind of represent a side effect using just immutable value. I also want you to notice this plus sign before an A, because this is how we express variance in Scala language. The variance refers to how a subtype in between more complex type relates to subtype in between their components. So what does it mean? Let's look at these types, class foo, class bar, and differ C, and the ADT I present on this slide. So the given class foo is plus A means that this is a covariant class, and the class bar with minus A means that this is a contravariant type. And if you have just an A, that means that this type is invariant with respect to its type parameter. So knowing this and the fact that car is subtype of vehicle, we could say that that foo car is subtype of foo vehicle. So because foo is covariant class. So we couldn't say the same about differ C because differ C car isn't related to a differ C vehicle. So again, because this is invariant class. Now let's talk about the difference between the regular IO and like Bifunctor IO. So we already know that IO could fail with throwable. So this is, and because of that fact, you have dynamically type errors in your code base. So every time a computation fails, you need to kind of perform pattern matching and decide what exact error type you have. On the other hand, BIO is actually does pretty much the same IO can, but it exposes the second error type parameter. So you could kind of map over it and compose different programs that has different error types. Also, you don't have this overhead due to runtime error mapping. I also need to mention that we use BIO from Izumi framework, and Izumi framework implementation of BIO based on ZIO. So now we kind of finished with all this preparational stuff, and we could actually see the kind of possible approaches to work with DynamoDB in Scala code. So you have already known that Amazon kindly provides their own SDK in a variety of languages. Still, you don't have kind of possibility to use they doesn't provide a Scala SDK, so we could try to use kind of Java code directly in Scala. To do this, we kind of first of all need to create a client using a specific builder. This approach is widespread across the library and provides great flexibility while cooking requests, but looks a little bit wordy. Here is our next step. It's kind of utilitarian. We need to actually create the table. And here is we kind of, for a ledger table, it has pretty simple. So we have key schemas that contains only hash part, and we provide the provisioning throughput, table name, billing mode. But you could already see that you are required to load a lot of boilerplate code while kind of cooking requests like this. So this example takes a whole slide actually. So Now let's take the later implementation. Um, First of all, do not bother yourself with this F type here. It's just a summoner of bio hierarchy. So instead of writing bio with F parameter, we just use an F, and sync blocking means that I want to kind of run this query in the separate blocking thread pool. So first of all, you should notice that using Java directly in Scala code, you need to take care of encoding and decoding case classes or kind of data structures you want to store in the database. Here is we kind of iterate over our result and use pattern match to do this. The second thing you should take care is this process pages, the pagination actually. Here is how I've implemented this. So, but writing this function is like the moment you started to write this function, you realize yourself writing another DynamoDB wrapper because you need to facilitate the amount of boilerplate code and to keep you kind of code base neat and clean. Definitely, this approach has its own benefits and disadvantages. It's pretty straightforward and easy to use. You don't have to invent the wheel, just like import the library and start to work with it right away. But it requires from you a lot of boilerplate code and kind of breaks referential transparency if you don't use any effect type like IO or BO. And but this is a very kind of powerful feature of functional of a code base written in a functional way. So maybe that is not the best solution out there, and we could kind of find something more appropriate that satisfy our requirements. And the next best thing you could do as an experienced and good software engineer, you could ask Google for help. And I bet you could find a Scanemo. Scanemo is a library that simplifies access to DynamoDB. It's written by cool engineers from Guardian. Here, let's take a look at how Scanemo could kind of help us to solve our problem. Here we have some example from the official docs that I've shamelessly copy-pasted. So basically we need to do, again, this preparational stuff like creating the client, tables. But the important thing you should note is that you need to define table using this table data type. So you parameterize it with this team case class. And that means that you kind of can only put and retrieve the data only this, you could put and retrieve only this team case class, only that case class you could work with. So it's kind of a restriction of Scanemo because Dynamo allows you to retrieve and put different sets of attributes and from query to query. But Scanemo kind of supports batch requests. It also supports kind of all operations related to the table items. And they even provide another interpreter that use Alpaca to allow you to have a truly asynchronous separations while working with Dynamo. It also requires from you to have Alpaca client and Akka kind of system additionally created. But it kind of has actually all things you need to have while working with Dynamo. And it seems like match in heaven, but there are throwbacks. First of all, Dynamo doesn't support AWS SDK second generation. It has very strict DSL, so if you haven't found the operation you want to use, you need to create your own solution. And it doesn't provide you rich Dynamo operation support, because in the real world you kind of benefit from some utilitarian functions like list tables, update tables, and stuff like that, but you couldn't do this with Dynamo. And again, some restrictions that I've mentioned before using this stable data type. So this is the reason that actually lead us to invest our effort and time into creating our own solutions to work with Dynamo. And I am so excited to present you today the D4S. It's a DynamoDB database done Scala way. So let's go ahead and look how the implementation with D4S would look like. Of course, first of all, we need to create the table, but instead of writing and using Java builders for that, we kind of extend the table dev trait that has this table reference and TTL fields. So essentially, table has its name, keys. You could also provide namespace and specify TTL. And for this simple case, we have only the main key. Main key we describe like with Dynamo key data type, and specify that this field has UUID type. I also explore this main function here, main full key function, but this is not a mandatory thing. This is just a matter of taste. Also, I want you to notice that we kind of pass implicit Dynamo meta here that is required by table DDL constructor. It has all information about provisioning, throughput, billing mode, and stuff like that. So also we need to take care of decoding and encoding our data types that we want to store in the database. So here you can see we provide codecs that uses Magnolia backend to derive type class from the case classes. We also provide Sears backend. If you want, you could just import the D4S Sears package. So here is how ladder persistent implementations look like. So here we have a connector data type that runs our query. It's very similar to kind of here you have very similar code to Dynamo. So Dynamo uses an interpreter and exec function to run the query. We have connector plus run this function, run function, but we don't use a free monad to kind of under the hood. So basically all methods like scan, update, or etc. They are implemented like extension methods over this table reference data type. And I will also want you to notice how easy it's to handle paginated requests. So we just saying that we want to process every single page and flatten the result using the exact page flatten. And the code base looks compact and neat. So the only thing we forget to do is to take care about our dependencies, like create tables, make configs. Of course, you could do this by hand, but we inclined that it's better to use the stage for this. So we expose the D4S module that kind of creates all this stuff like Dynamo clients, Dynamo health check, table services. So you just import it into your code base. And it's also very convenient to use this stage to handle all your kind of dependencies headache. So now we have already seen how the implementation of the ladder persistent looks like, and we could see other features of the library. So previously we just simply run a query and got result as it is. Besides that, D4S provides a convenient way to work with queries using F2 streams. We just need to use this corresponding run streamed function of connector. And while building the query, you need to use exec stream to specify that it needs to be executed in a streamed fashion. Very interesting thing on that slide that you might notice. This is a retry with prefix combinator. So it's actually a very distinguishable feature that nobody has. So, and it's made to kind of satisfy multi-tenancy restriction. So sometimes you need to kind of store the data for several customers or apps within the same infrastructure, and you could use the prefix tables to do that. So retry with prefix, by using retry with prefix, we are actually saying that we want to kind of run the query against the prefix table. But if it's not available or if it's not created, so we create the table and then run the query, or we just retry several times to actually perform this query. We support batch operations using delete item batch or get item batch, but we also could do even more. Here we have a query delete batch request. So sometimes you don't have enough data to perform delete items batch, but you could kind of query your database, extract the data, and then perform the delete item batch. So we kind of simplify this and create a specific query for that performs query request and then perform delete item batch in parallel. Again, you could handle pagination with elegance using D4C. We also support conditionals, and here we have several examples of conditional queries. In the first one, we use if not exist plus op conditional failure. It's obvious what the if not exist does. In turn, op conditional failure returns some value when condition is not met, and it returns none for other errors. In the next two queries, we have kind of example of begin with predicator and simple Boolean functions like and equal to build the condition. In case you don't want to span a lot of traffic getting redundant information, you could use a projection expression combinator. Here we just specify that we want to get, we want to get only the score attribute. So one of the important goals, design goals of D4C was ability to kind of modify already completed queries. So you cannot do this with Dynamo in case of free monad, but with D4C, even if you kind of created the query, so while working with such combinators as update item, you're working with Dynamo query data type that represent an abstract query. But we need to kind of transform it to Dynamo execution type that contains the query and knows how to execute it. And even having this type, you could modify the query and run it. So this is very convenient. Of course, we could describe secondary indexes. We just use global index or local index, depends on which type of index you want. You just need to provide a name for the index, describe the key. In the same fashion, you describe the key for a table and provide a projection. Then you just pass it to a DDL, to a local indexes or global indexes. That's it. So DynamoDB actually allows you to update particular attributes while running the request. And this is a very cool feature, again, because we don't move a lot of unused data back and forth, only to update the stuff you need. So the D4C allows you to do this with less boilerplate code. This withUpdate expression function takes a string that tells kind of what field we want to update, and we just use regular DynamoDB syntax for that. As you can see, Dynamo D4C probably covers all situations that you could encounter in your daily job. But if it hasn't, you could describe a request you want using the row requests. Here is, I've described a row request to query a table limits. We need to provide a request itself using the toAMZ function. So here we use these Java builders. And you need to provide a function that tells how to interpret this query. So using this interpret, we kind of tells how to interpret our request. On the other hand, you could use this row function from the companion object of row request and just provide Dynamo client and run the particular query you want in that way. So this is kind of two ways to do kind of your custom request. So a few things I need to mention. First, it's we support TTL Field. So you need to provide it like an optional type parameter to the table reference. And we have this convenient filter TTL combinator that kind of filter out all expired records in case Dynamo haven't done this yet. So, and also we have, and we do utilitary operation instead of you. So we provide a Dynamo table service that has all this utilitary stuff like create a table, delete table, list tables, and Dynamo table service actually starts when the application starts due to usage of D stage. You can also achieve the same using the connector and dynamic execution. I mean, you could also call this list tables function, but in using the other way, like connection and dynamic execution. So as you can see, we support rich operations, rich support for different kind of operations in DynamoDB. We support batched row requests, complex queries, utility functions. So we cover a lot of stuff. the library itself is kind of low level, but it gives you more control over while working with DynamoDB. But in case you are not happy enough, we have provided additional features that kind of makes you more productive. First of all, as I've already mentioned, D4C is powered by Izumi framework, especially this stage. And we believe this stage makes your daily job easier. This is why we expose these stage modules that you could just add to your existing project, and then DI will take care of your dependencies headache. Here is the example of D4C module. This is part of D4C module where we kind of create a client, connector, interpreter, table service, and TTL service. This stuff that kind of helps you because of using this stage, you don't need to worry about this preparational stuff like table setup, because all these setup things would perform on the start of the application. So no more table setups. Also, very cool feature that we have is this stage collects metrics for you. And the important thing, you could get these metrics over HTTP, like in the example I showed. You just need to expose the endpoint for that. We provide a metric extractor that kind of extract all metrics into a convenient like metrics list, and you could pass it over. We also use structured logging library log stage, also from Izumi, and this provides a very convenient logs for you. A few additional things. I mentioned earlier that we have implemented codecs using Cirrus and Magnolia. We also provide stuff like health checks for you, so you don't need to worry about the kind of connection, is connection stable or not. In case you are a great fan of Zio and ZONs in general, you could also use Dynamic Connector inside ZON. And we support Scala 2.13 and 2.12. So it's kind of, that's it. That's all I have for today. I guess I've kind of did it faster than expected. So I've attached several links at the end of the presentations that you might found interesting for you. So here is a D4S link and showcase repository, and of course link to Izumi framework. So in case someone has a question, I could answer it.
So maybe actually one question is about like how did you approach the so your library works with this stage as far as I remember. So is it also possible to use it with different effect systems like Cats effect or Zio? And how did you approach this interoperability?
So basically, yeah, you could use it with Zio. It has great interop because we use Bifunctor IO, and our implementation of Bifunctor actually based on Zio. So about cats, Izumi provides a great cat Z interop module. So you could use it from Izumi as well. So basically, Izumi provides everything you need to kind of to handle this kind of situation. We just like use this functionality in our library. That's all.
Okay, cool. Thank you.
So I have a question. it sounds as though what you've done works well with the Amazon Cloud NoSQL database. Can it be easily adapted to work with other cloud-based NoSQL databases? So for example, at work, like I use Amazon Cloud myself personally, but at work we're using the Microsoft Cloud because we have a relationship with Microsoft. And so they have their own NoSQL implementation, and you know, but we do a lot of Scala at work. So I was wondering if I could use your stuff for the Microsoft Cloud NoSQL.
Basically, not, because G4S uses an SDK from Amazon. So we use Amazon SDK to, you know, implement request itself, like under the hood. So we cannot just, if we could, you know, replace this kind of dependency and use Microsoft. So in that case, yes, but we use Amazon SDK to implement requests. So
right. Yeah, it's not a big priority. You know, when we do NoSQL stuff, we tend that isn't usually the Scala code that's interacting with it. It's actually more batch process oriented kinds of things. But I was just curious, you know, about how flexible it was if someone wanted to use it for just any old NoSQL.
oh, okay, understood.
But that's good. It still sounds useful for my personal stuff.
Great.
Any recommendations, any thoughts, you know, to share with the site?
Okay, my recommendation would be the book, so that I found really useful and helpful in case of you want to do NFP stuff, but really practical, in a practical way. So it's the book by Gabriel Wolp, the hands-on FP in Scala and hands-on approach, I guess. So it's called something like this.
Could you write down this name to your Slack channel, please?
Oh, okay, yeah.
It would be awesome getting such recommendation in written.
Yeah, so
good.
Few minutes. Oh yeah, that's it. Yeah.
Great.
Practical FP. It's I think it's a good book, you know, because it's illustrated on the real case.
Thank you, Jeffrey. Yeah, thank you for your hint.
Yeah, didn't that book just come out? Because I just heard about it and I just got it.
I've, you know, pre-booked it when it was a draft.
I see.
So yeah.
Good. Thank you. It's a good point.
Thank you for the opportunity and for all these questions.